Welcome to qnawire.
Okay, we need to draw an isomer of C4H8Cl that is least reactive in an Sn1 reaction. Now recall that Sn1 reactions require our leaving group, which in this case is chlorine, leaving on its own and generating a carbocation, right? And so in terms of speed or relative speed, the fastest Sn1 reactions will take place with tertiary carbons, which bear the chlorine, second fastest secondary, and primary, which is virtually impossible, or not impossible, but incredibly slow. So if we want low reactivity, we would like a primary carbon to bear our chlorine. Therefore, we can almost guarantee that we will start with something like this, a chlorine and then a carbon, and then attached to this carbon will be no more than one more carbon. Okay, so at this point, we have used 2 of our available carbons, and we can then place the remaining 2 either on this neighboring carbon, or we could generate a linear structure in which our remaining 2 carbons are not branching, but instead linear. Now note that if this chlorine were to leave and generate a carbocation, it would be a primary carbocation, but it would neighbor a tertiary center, and therefore a hydride shift could occur, generating ultimately a tertiary carbocation. That is not possible with this substrate, because if the chlorine leaves and generates a primary carbocation, we could do a hydride shift, which would generate a secondary carbocation, but we could never achieve the stability gained through a tertiary carbocation, right? And so for the slowest Sn1 reaction, we would want the substrate, which is entirely linear, which means that even after a hydride shift, the greatest substitution we could have for the carbocation would be secondary, right? So then our final answer would be the linear chlorobutane, or 1-chlorobutane, like so.